So to start this question off, I'm actually going to correct a typo. In this sentence over here, where it says the potential difference across it is above 5.5 volts, that should actually say below. And we'll go over why that should be below in a sec. So let's go back to the beginning. So we have a thermistor that's being used to control a heater. And it says when the temperature falls below a certain value, the heater is switched on. So for our thermistor, or for our circuit, the temperature is falling. If the temperature of a thermistor falls, then its resistance will rise. So the resistance of the thermistor rises. These two components are in series, and if the resistance of the thermistor is increasing, and the fixed resistor, well, it's fixed, it stays constant, and we have a fixed voltage supply across the two, 9 volts, that splits because these two are in series. The voltage will split in the same ratio as resistance for these resistors in series. So if we have a greater resistance for our thermistor, then the voltage across it will also increase. And the voltage across the fixed resistor, so remember that this resistor doesn't change, the voltage across the fixed resistor will therefore fall. So for our central heating system, we want it to turn on when the temperature falls below a certain value. And we see that when the temperature falls, the voltage across the resistor will also fall. And that's why it should say here, the heater circuit is connected across R and will switch on when the potential difference across it is below 5.5 volts, when it falls below 5.5 volts. Okay, so we also have a graph that shows the variation of resistance of the thermistor against temperature. So our graph here is a logarithmic graph. As you can see, the numbers don't go up in the usual increments. And also you can see that the lines that we have here aren't equally spaced. So how does this log graph work? So if this is 0.1, this here would be 0.2. This would be 0.3. This would be 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and finally 1. But then this would not be, this point here will not be 1.1. That would instead be 2. And this would be 3. And 4, 5, 6, 7, 8, 9, 10. This would be 20, and so on. Alright, so we're going to be using that later on in the question. For the first part, it says, with reference to charge carriers, explain why the resistance of the thermistor RT changes with the temperature. So for a thermistor, as you increase the temperature, that will move, or that will give electrons in our semiconductor some energy to jump from the valence band to the conduction band. And when they're in the conduction band, they can move more freely around as current. So that increases the charge carrier density. And if we increase the charge carrier density, so let's just write some of this down. So we have the temperature goes up. That increases the charge carrier density. If we increase the charge carrier density, we will increase the current as well. And that's because I is equal to NAVE. If this goes up, this goes up. And if we think about V is equal to IR, if we had a fixed voltage value across our thermistor and the current were to go up, then the resistance would decrease. All right, so let's write that down. And for part B, the heater switches on when the temperature falls below 20 degrees Celsius. Calculate the resistance of the fixed resistor. So if you look at our graph, 20 degrees Celsius corresponds to this point on our graph. Let me get rid of some of this. And it corresponds on the y-axis to this point, which is 0.7 kiloohms. So the resistance of our fixed resistor is 700 ohms. Okay, so if we go back to our circuit, so this has a resistance of 700 ohms, our thermistor. We're trying to work out the resistance of the fixed resistor. We know that it switches on when the potential difference falls below 5.5 volts. So if this is at 5.5 volts, it's at the threshold below which it will switch on. And the thermistor should therefore be at 3.5 volts because the two voltages should add up to make 9 volts. And then it's a ratios thing. So the ratio of voltages, 3.5 to 5.5, should be the same as the ratio of resistances. So it was 700 for the 3.5 volts, and the unknown resistance is what we're going to work out from this ratio. So we can make an equation from that. R over 700 is 5.5 over 3.5. R is then 5.5 over 3.5 times 700. And then we get a value of 1100 ohms, which will be our answer.